Optimization. A game doesn't work well, it's badly optimized. A game doesn't run at 60 frames per second, it's badly optimized. A game doesn't run in my potato computer, it's badly optimized. A game crashes, it's badly optimized. A game needs frame generation, it's probably badly optimized. So this is a word that's been thrown a lot around lately in social media, and if you follow any type of gaming news, you probably heard it too. But do people really know what this word means? What does it mean in the context of video games? That's what we're going to talk about today. We're also going to explain why is it that so many games nowadays come out, as everyone says, not optimized. So let's get started. Okay, so optimization. What does it mean? According to what I see on Google, it says the action of making the best or most effective use of a situation or resources. In this case, to put it simply, when it comes to game development, optimization just means balancing the equation. On one side, you have the hardware that you're trying to target, and on the other side, you have the game that you're trying to make. So you need to make this game that you're trying to make work with the resources that you have on that hardware that you're trying to target. Now, it's not that simple, and it involves the whole team when it comes to game developers, coders, user interface, artists like myself. So we're going to be focusing on my area of expertise, which is the visual area and how that part is optimized. First is triangle count. So everything that you see, if it's a 3D game, it has triangles. Everything that you see on your screen has an amount of triangles. Now, a video game cannot do an unlimited amount of triangles. Usually, for engines that are not Unreal, you can go between 1 and 5 million polygons at one point in a scene, including characters and all that. But when it comes to Unreal Engine, at least Unreal Engine 5, now with Nanite, you can go all the way to like billions of polygons. It's ridiculous. We'll talk about Nanite later in the video. Now, this is something that you've heard me talk a lot in my Dissected series. I always talk about the try count of the characters, the environmental pieces, the weapons, and this is all very important in order to maintain some level of optimization, because like I mentioned in the beginning, unless you have Nanite, you're gonna go all the way ridiculous and have millions and millions of polygons just for one single assets. Now, this leads us to LODs, or levels of detail. Now, the LODs is simply a different or smaller version of the asset that is usually used the further away that you are from that asset. And that is what produces the famous pop-in when you have a tree that looks like a cardboard cutout look better as soon as you cross a threshold. That is the next LOD loading. The same thing is for characters. Characters, for the most part, all of them have a certain level of LODs. Engines like Unreal can create LODs for you. Actually, metahumans have 8 levels of LODs. The level 8 doesn't even look like a metahuman. It's horrible. Now, let's talk about Nanite, because Nanite is pretty much another type of LOD. When Nanite came out, a lot of developers were very excited because it was the promise, and I'm saying promise for a reason that I'll explain a little bit. It was the promise that you don't have to go through the whole pipeline of reducing your assets poly count. You could just have assets that are scans and just throw them in like mega scans. Mega scans, you could throw in the highest poly count in and it will still look great. There's a lot of detail that we fake with normal maps. We're going to talk about normal maps in a little bit, but if you can do it with geometry, it's always going to look better. Geometry always going to look better than normal maps. However, the problem with geometry is very costly. Now, Nanite is supposed to solve this problem. The issue is, even if you have something like this, which is a quick example that they made for Unreal Engine 5, you can see that this thing looks gorgeous. It has gazillions of polygons because all the assets are at their highest. However, you can see the frame count here on the scene. You see that it's running 50, 60-ish. And if I get more into like the interior part of the scene, is going to lower the frame rate. So even with something like this, it doesn't mean that the game is going to perform well if you throw all the assets at the highest resolution possible. When it comes to geometry, you still have to take into account the geometry that you have on scene. Also, the higher the resolution, the more space is going to take on the hard drive. So that's another optimization thing that we need to take into account as developers. Now, the next one is textures. So textures are pretty much the colors that you see on everything. Everything has a texture for the most part. Sometimes things are just created within the material inside the engine, but I would say at least 90% of the things that you see inside a game are made with textures. Texture is something like this. It's just a map, usually squared. Now, some engines can have textures that are not squared. I've shown that in my Dissected series before. There's a playlist down below if you want to see that. So when it comes to textures, there are a couple things you need to decide. How many textures you're going to have per asset, and how big are these textures going to be. So you cannot have, let's say 10 textures per asset on scene, because if you have, let's put it like 150 assets on the scene, and you have 10 textures per scene, that's going to be way too many draw calls. And draw calls usually is what bottleneck the performance. So you need to reduce the amount of textures that you have on per asset. One of the ways that you reduce this is by using atlases. So you have one complete texture sheet for several assets. This is something that we saw in the Dissected for Elden Ring. Another way that you can do this is if you have a character that is interchangeable or is customizable, you usually use mask for colors and other things instead of using a texture map for each different skin of your character. You can do so by masking inside of your engine, and that reduces a lot the amount of textures that you have. Another way to reduce the amount of textures that you use is just by creating the material within the engine. Because for instance, in Unreal Engine, you can create a lot of variations just within the engine without having to call up textures from the outside. Now, one of the textures that is very important today is the normal maps. Normal maps is the way that we transmit detail into the model. Is used a lot in characters, is also used a lot in environments. The reason why we use normals is because it's always easier to load the detail from geometry into a textures as opposed to have the geometry all together. This was the purpose of Nanite, but even if you're using Nanite assets still have normal maps. So this isn't something that we have gotten away from. You still bake the assets, you still bake the normals, because there is detail so small that if you have it as geometry, it's going to be ridiculous, the amount of polygons that you have on scene. Now let's move on to the next thing that usually tanks performance, and this is a big one. This is one that's been talked about a lot, and that is lighting. So when it comes to lighting, nowadays we have two types. We have baked lighting, or we have real-time ray trace lighting. There's pros and cons to both. Usually go more towards the side of baked lighting, although baked lighting is not perfect. There's some issues there as well. So the reason why baked light is usually the most optimal way for video games is because instead of that light being calculated real time, you have that light already stored in a texture inside the asset. So you load it in memory, it's there, it's done. It can be as high as you want, it can be as low as you want. Now, there are caveats with this because these textures occupy memory, so you have to take that into account when you're running your game. Now, the other problem with baked lighting is that when it's baked, the shadows can just be there. It's harder to do like dynamic lighting. It's not impossible. Actually, there's a lot of games that have baked lighting that also have dynamic lighting, but it's not as easy to do dynamic lighting if you have baked lighting. There are other things you need to take into account. Some game engines like Decima have pros that take care of this. I believe Digital Foundry mentioned that this is also how dynamic lighting is being done in Ghosts of Yotei, which just released not long ago. So there are ways to get around that. However, if you don't use baked lighting and you use fully ray trace lighting, you don't have to take a lot of things into account. You can just throw your things in and run your game. The problem with ray trace lighting is that ray trace is calculated in real time. That means it's occupying a lot more resources on your GPU that could go towards something else. So that means that that game is spending a lot of time calculating the lights, and even worse if you have more than one lights on a scene. So not only do you have to think about which type of light you're going to use, you also have to take into account how many lights are on your scene, because each light calculated for every single asset is going to start tanking your performance. So that was the promise of Lumen inside of Unreal Engine, was supposed to do this ray trace global illumination solution that would not be as performance intensive as actual ray tracing. However, from what I've seen, it has caused all sorts of problems in video games. I use Lumen all the time on my projects, but I don't do video games. I do 3D animation. So for me, it has worked fantastically. I also use Lumen hardware all the time. From what I've seen, a lot of games are using Lumen software, which tend to produce a lot of artifacts. Lumen hardware works a lot better, in my opinion. The problem is using Lumen hardware also limits the amount of hardware that your game would be able to run on. So another thing to optimize. And then we come to reflections. Reflections are a big one. Even though I'm putting it last, it's very influential when it comes to how your game's gonna perform, because if you're doing something that's sci-fi, that has a lot of surfaces that reflect stuff, reflections look cool. It makes your game look a lot more realistic. But if you have too many reflections, especially if you have ray trace reflections, you're going to tank performance, because imagine having to calculate all those things. Your GPU have to calculate everything that's supposed to go into the reflections. Now, there are ways to do it in a non-ray trace way. Inside Unreal, we have this field reflection capture where you place it in an environment, it captures everything around it, and then it projects it on the surface that are supposed to be reflective. But I see some games are trying to use more ray trace reflections, which again, they look great, but they tank performance. There's also the screen space reflection, which is the most common one that you see in video games. The problem with this reflection is as soon as you stop seeing that thing, like if you turn around, maybe you can still see the reflection, but because you turn around from that object disappears from the reflection. Now, those are all the things that you can play with when you are trying to optimize the game. At least from the visual side, there's other stuff from the coding side and from the engineering that need to be dealt with in order to optimize the game. But from my side, that is what you deal with usually. And as I talked in the beginning, optimization is balancing an equation. So you have all these things that I just mentioned inside of a video game, and over here you have the hardware that you are going to run it. And now we get into the question of why are so many games not well optimized these days? Now, I know somebody in the comment section is going to instantly write, it's because of Unreal Engine 5. But in my opinion, it has a lot to do with the hardware that we have nowadays. Now, if you're a developer, sad to say this as a member of the PC master race, but it is easier to optimize for a console than it is for a PC, because you only have to target one type of hardware, or maybe two if you're doing Xbox and PlayStation, maybe three at most if you're doing Xbox, PlayStation, Switch. Although that one's very different because of how underpowered it is. But the problem with the consoles of this current generation is that, in my opinion, when they came out, that means the Xbox Series X and the PS5, they were already outdated. By the time these consoles came out, they already were running on outdated hardware. So there's not a lot of room to work with when it comes to performance, and that is why you see all these games that are trying to push high fidelity that have a hard time hitting certain frame rate. However, on console, I think the max is usually 60 frames per second. I know some people have mentioned that certain games on the PS5 Pro can run up to 120. Again, I don't have a PS5, so I don't know. It's just what people have told me. Let me know in the comment sections down below. if you know of, or which games are actually running at 120 frames per second on a console, because I really don't know. But the issue is, yes, you optimize to one hardware, but the amount of hardware that you have is very limited. The GPU, the CPU, everything inside current generation console is not that powerful. And studio heads are demanding that games look more and more realistic. So there comes a time when there's only, aside from Borderlands is a different story altogether. But when it comes to like realistic looking games, there comes a time where there is only so much you can do until that visuals start degrading and it doesn't look great. Developers have to decide, well, do we run this at higher than 60 and it doesn't look like today's current gen, quote unquote, or do we run it at 30 frames per second and maybe we throw in one of those cheat codes that we have nowadays called frame duration? That's one way to go. And that is one of the things that I see developers are doing nowadays, because you have to play with the software that you have. I don't know what the next Xbox is going to be or the next PS6 is going to be, but what we have today, it's sort of limiting when it comes to the visuals that games need to have. And I know there's the argument that games don't need to look much better than what we have in 2017 or 2015. I get it. Maybe you think that way, but the general public gets excited whenever you see a super high fidelity game. The most recent that I can remember was when Kojima Productions revealed the odd knocking, I think OD knocking, and everybody went crazy because of how realistic that games look. Look, realism sells. Whether you agree or not, that's another thing, but it's a fact that realism sells. Developers are going to keep pushing for it. So then we have the problem of frame duration, which is, a lot of people will tell me like, why you hate on frame duration? You know, it's trying to make your game run much better. The problem with frame duration is that it makes studios want to hit a target that isn't there. What do I mean by this? A studio needs to have a game that is super high fidelity, and they can only do that high fidelity if the game is running at 30 frames per second. But a lot of people are starting to say, well, 30 frames per second is not acceptable. I don't think it is, but some people say it's okay. So what do developers do? Well, you can either lower the graphical fidelity or you can use frame duration. The problem with frame duration, to be honest, is that I always thought frame duration was supposed to do what it does in Dying Light, where if you saw my video, you see that game runs perfectly well without frame duration. I have it running on native, and if I turn on frame duration, the frames just goes through the roof, which is, in my opinion, how it's supposed to be. But more games, and here's what we call Borderlands 4, they're just targeting, okay, let's just do, this game works fine, and it blows my mind that a game that is stylized and that doesn't have that much geometrical detail targets 50 frames per second without frame duration. This game should be running at 120 frames per second without frame duration. I believe tinfoil hat on that they told Gearbox that we're going to be using this game to promote frame duration. Maybe not, maybe I'm wrong, but I think that's what it was, because I don't understand the reason why this game that doesn't look much different than the other Borderlands needs so much more hardware in order to run correctly. Now, another thing that I need to mention when it comes to optimization of video games today is, well, this is a little bit of conspiracy, but it's also true, is the fact that games are more demanding is because console makers need to sell hardware. I think games peaked visuals at around mid PlayStation 4, but they needed to keep pushing it, because otherwise, if they don't push it, then why are you going to buy a new hardware? See, the consoles are not these things where they get damaged and then you go and buy another. It's not, at least it's not a thing that is usual that your console, like I've had PS4 for I think almost a decade now, and it still works fine. And I know a lot of people that have consoles from like the heyday in that console, like Nintendo or SNES, and the console still runs fine. So consoles are a product that you only buy once. So if developers don't push games to require more hardware, consoles don't sell. Same goes for PC. If the game comes out of PC and doesn't require more hardware, then you don't buy a new GPU and all that. Now I'm going to get a little bit into something that I've seen on Twitter lately, is that people are saying like, well, you can build a PC that is cheaper than buying a console nowadays, because one of the most ridiculous things that I've seen is that consoles actually going up in price. You got hardware that is outdated and it's going up in price, which to me it's mind-blowing that we're in this timeline, but we are. Some people are coming out and saying, well, just buy a PC. A PC like this can cost you a lot less than a console. The problem is that PC that costs you less than a console is not going to give you the PC experience. If you want the PC experience, you have to spend at least $1,500, probably $2,000. That is just the reality of it if you want the PC experience. And that is why, even though I'm part of the master race and I've always played on PC except for the PS4 that I have because of exclusives, if you don't have a budget, then get a console. I always recommend a console if you don't have a big budget, because a console is it's way more convenient. And if you don't have a big budget for a PC, then you're probably going to get a lesser experience than what you would get on a console. Now, I also do not recommend people to get what I have. I have a 5090 with a 16-core CPU. You don't need that unless you do what I do for a living. But if you just want a computer for playing video games, 4090 would do great. 3090, like the one that I have, still a fantastic computer. It's just a little bit behind from what I'm doing right now. So now that you know what optimization is, what do you think? You think games need to use all those ray tracing stuff, or are you good with a video game that used backlighting like back in the day? Or do you still need those super high shiny reflections? And that's not a bad thing, you know, it's subjective. It's what do you want to see? Let me know in the comment sections down below. Now, there's another piece of the puzzle when it comes to optimization, and it's shader compilation. It's a huge deal when it comes to Unreal Engine made games. But this video is already pretty long, so I'll talk about that in another video. So make sure you subscribe and ring that bell for notifications so you know when that video comes out. Leave a like and leave a comment, because it goes a long way to helping the channel get out there. Thank you so much for watching all the way to this point. I'll see you in the next one.